Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Intramolecular aldol condensation involves a decarbonyl compound undergoing an intramolecular aldol reaction, nucleophilic addition of an enolate to a carbonyl within the same molecule, followed by dehydration to give an alpha-beta unsaturated carbonyl compound. The product is a cyclic enone formed by ring closure. Step 1. Analyze option A1 indane 1-1 or indane 1-1 is a bicyclic compound with a 5-membered ring fused to benzene containing a conjugated enone. This can be derived from 2-formyl phenylacetaldehyde or a related odaldehyde via intramolecular aldol condensation forming a 5-membered ring. This is a valid intramolecular aldol condensation product. Step 2. Analyze option B2 cyclohexane 1-1 is the classic product of intramolecular aldol condensation of 1,6-hexanediol or cyclization of adipaldehyde, or more commonly it arises from the intramolecular aldol condensation of a 1,5-diketone, like 2,6-heptanedione giving 2-methylcyclohex-2-enone. 6-membered ring formation by intramolecular aldol condensation is very favorable. This is a valid intramolecular aldol condensation product. Step 3. Analyze option B. The dicolone, bicyclic saturated ketone, octahydronaphthalene, could arise from intramolecular aldol condensation of a linear diketone, but the product shown is fully saturated with no double bond. An aldol condensation product requires dehydration giving an alpha-beta unsaturated carbonyl. However, an aldol addition, without dehydration, gives a beta-hydroxycarbonyl and reduction could give saturated product but strictly aldol condensation gives an enone. Still, a saturated dicolone could be obtained by intramolecular aldol addition followed by reduction, or it could be the product of an intramolecular aldol condensation followed by hydrogenation. But in context, this can be rationalized as deriving from intramolecular aldol condensation of a 1,9-diketone. Step 4. Analyze option C. The structure shown in C is a compound with a benzene ring fused to a 6-membered ring bearing a ketone and an exocyclic methylene is equal to CH2. This structure, 2-methylene-1-tetralone or similar, has an exocyclic double bond rather than an endocyclic conjugated enone. An intramolecular aldol condensation would give an endocyclic double bond in conjugation with the carbonyl, an enone, not an exocyclic methylene. The exocyclic is equal to CH2 adjacent to a carbonyl in a ring is not the typical product of aldol condensation. It resembles more a Mannich or Knoevenagel-Wittig type product, or a Baylis-Hillman product. The condensation step of aldol involves loss of water from the beta-hydroxycarbonyl to give the thermodynamically favored conjugated enone, which would be endocyclic. An exocyclic methylene ketone is not the expected product of intramolecular aldol condensation. Step 5. Conclusion. Option C is not the product of an intramolecular aldol condensation because it bears an exocyclic methylene group rather than the endocyclic alpha-beta unsaturated carbonyl system that aldol condensation produces. Therefore, the correct answer is C. Therefore, the correct answer is option C.